Hello students, welcome to the session. Here in this session, we are going to discuss about JK flip-flop using NAND gates. So in the last session, we discussed about the JK flip-flop. So now let us see the JK flip-flop truth table once again so that we'll have an idea regarding what is the disadvantage with respect to JK flip-flop. So in JK flip-flop, we have this is the truth table. When both the inputs are 0, 0, we'll get the output as Qn. Here you could see that it is Qn plus 1 represents the present state and Qn represents the previous state. So it is when J and K both are 0, 0, we are getting the previous state. So it is the present state is equal to the previous state. So thereby we say that there is no change. Okay. So when J is 0 and K is 1, we are going to get the reset state. And when J is 1 and K is 0, we are going to get the set state. And J and K, when both are equal to 1, 1, we are going to get Qn bar. Qn bar is what? Complement of the previous state. So this condition, it is called as toggle condition. See, the meaning of toggling is output is 0, it becomes 1. If the output is 1, then it becomes 0. That is output in the sense it is the previous output because these are all flip-flops. So here what happens, we could see the toggling condition over here. So this toggling condition, you could see it here. I have mentioned this toggling condition. So this here in this case, when both J and K are equal to 1, so output is toggling. See, this is the condition which is called as the race around condition. So the meaning of that is output is continuously changing from 0 to 1 and 1 to 0. And what is the state of the flip-flop, that could not be determined. So that is called as the race around condition. Here now let us see the JK flip-flop using NAND gates. So flip-flop can be constructed using any of the gates. Here is one more example in which we could construct JK flip-flop using the NAND gates. So here is S bar R bar latch. So using S bar R bar latch and using 2 more NAND gates with 3 inputs, we could construct the JK flip-flop. So in this JK flip-flop, first why we are coming for this JK flip-flop is a point. So first we discussed about the latches. So upon disadvantages with the latches, because they all work on the asynchronous inputs, we want to synchronize that one. So we came for flip-flops. So first we discussed SR flip-flop. So in the problem with SR flip-flop is that when both the inputs are equal to 1, 1, that particular condition, it is known as the indeterminate state. So we want to overcome this one. So in order to overcome this indeterminate or invalid state, we could come to the JK flip-flop. So in JK flip-flop, it is the advancement with respect to the SR flip-flop. So here in JK flip-flop, what happens is we could eliminate this invalid condition, but still there is a problem. So what is that problem is that when J and K inputs both are equal to 1, 1, see output is continuously toggling. That means output it changes either from 0 to 1 or it is from 1 to 0. So now let us consider initially now when J and K both are equal to 1, 1 and Q is 0. See, after certain time interval which is called as delta t, and this delta t is called as a propagation delay through the NAND gates. So the output, it will change to Q is equal to 1. Initially we assume that Q is equal to 0. So after certain time which is called as propagation delay, output is going to change to Q is equal to 1. Then what happens is after one more delay like this, again it will change to Q is equal to 0. So after certain again delay, so delay is what? It is again the time interval delta t. So this toggling, it will continue until till the time it is enabled. That means until you give clock signal, until it is triggered, this toggling will continue as long as J and K both are equal to 1. Okay, so what happens is once we disable this flip-flop, then we could not decide that what is the output of the flip-flop. That means we cannot say what is a value of Q. So it is uncertain. So this uncertainty, it is mentioned as, or it is technically, it is called as the race around condition. So this race around condition exists when this TP, whatever I said, that is the time interval. So as long as this TP is greater than this delta T. Okay, so there are few methods in order to overcome this race around condition. So the first condition is that the first method is that by using this, the TP is what? It is the propagation delay. So as long we keep this propagation delay less than delta T, so delta T is the time interval. So as long as it is less, we could overcome this race around condition, but it is quite difficult practically in order to implement. So in order to overcome this, we have second solution for it, which is called as the master slave configuration. So we need to have to use master slave configuration. So now let us move on in order to discuss this master slave flip-flops. So these master slave flip-flops, they consist of two cascaded sections. So both the sections, they are capable of storing 1 bit of information. The first section, it is called as master, and second section, it is called as the slave. So information that is entered into the master in the first edge, or it is level, generally it is flip-flops, so it will be edge triggered only. So the information that is entered into the master in the first one edge, then of the control signal, and then it is transferred to the slave on the next edge. So thereby we could avoid this race around condition. How we can avoid this race around condition? We need to have to see using this master slave JK flip-flop. So actually master slave combination, it can be constructed for any type of the flip-flop. So master slave JK flip-flop, actually it consists of JK flip-flop as master and SR flip-flop as slave. So output of the master flip-flop, it is fed as input to the slave flip-flop. Okay, so but clock signal, it is not directly given. So here you could see that how it is constructed. Clock signal is not directly given to both the flip-flops. Initially, it is given to the master flip-flop and it is passed through the NOT gate. After that, it is given to the slave flip-flop. Okay, so that is the speciality with respect to master slave flip-flops. Okay. So at the positive clock pulse, information that is present in the J and K inputs, it is transmitted to the output of the master flip-flop and it will be held there. So after that, during the negative clock pulse, when the negative clock pulse arises, so when it arrives, so at that time, it is passed on to the slave flip-flop. So that is how it is going to work. So here is the logic symbol that you could see. So here is one JK flip-flop. So here what we can show over here is all this is the JK flip-flop and here we have the SR flip-flop. So how we have constructed is JK flip-flop, it is the master flip-flop over here and SR flip-flop is the slave and you could see that clock is directly given to the JK flip-flop. So but it is not directly given like this, but it is passed through the inverter and then that is given as input to the slave flip-flop. So that is how it is constructed. Okay, now let us move on in order to see the master slave JK flip flop. So this is one example wherein we could construct the master and slave flip flops using these NAND gates. Okay. So here one more thing that you need to have to observe is, and Q1 bar, it goes to the R2. Okay, so that line is missing over here. So actually it goes to R2 input. So that can be taken. So now let us move on to see the operation of this. So in the operation of this master slave JK flip flop, so how it overcomes the race around condition, that we need to have to see. So first let us consider j is equal to 1 and k is equal to 0. So as we all know that JK flip-flop truth table, we are already familiar. So if j is equal to 1, master's flip-flop is going to set. So at what time it is going to set? It is going to set on the positive clock. So the output of this master flip-flop, which is called as Q1. So this Q1 is given as input to the slave. So where it is given, it is input to the slave is Q1 is the output. This is the master. Output is given as the input to the slave. So it is nothing but S and R flip-flop, right? So it is S input. So output of master goes as S input of slave. Okay, so that is how it is given. So this S input of slave, so what happens is, so during negative clock, okay, because they have been designed such that, because we are giving the clock signal, because that is the purpose we are giving an inverter over here, so that master is active during positive clock and slave is active during negative edge. That is why we are making this now inverter over here. So here we'll come back and we'll discuss. So when j is equal to 1 and k is equal to 0, what happens is master is going to set, because j is equal to 1. When it is going to set, it is on the positive clock. So output of Q1, okay, so this output of Q1, of the Q1, that is the master output. So that is going to drive the S input of slave, and it is going to do such that it is during the negative clock, this slave is going to set. So why it is going to set? It will copy the master. So it will copy the action of the master. So now let us see the another input, how it is done. So when j is 0 and k is equal to 1, obviously we know that if j is 0 means we are going to get reset condition. So master will reset. So when it is going to reset? During the negative clock. So the output Q1 bar, it goes, so here it is, the output Q1 bar, it goes to R input of the slave. Is it not? It goes to the R input of slave. So therefore, at the negative clock, this slave is going to reset. Alright. So now let us see the next condition. So this condition is very important, wherein we have both the inputs as 1 1. So when both the inputs are 1 1, master flip flop will toggle. Okay. So when it toggles on the positive clock, okay, because it is active during positive clock, and slave is going to copy the master on the negative clock. So that inverter plays a major role over here. So thereby what happens is, so at that instant, the feedbacks that are given as inputs to the master, so these are complemented, but it is the negative half of the clock pulse. Because it is the negative half of the clock pulse, our master is inactive. Okay, so our master is inactive. So because of that, it will prevent the race around condition. So here in the previous case, you could see that Q and Q bar are taken directly from there over there. So because of that, since feedback is available, Q is going to set and reset. Now it is not happening. Okay, because during the positive edge, master is going to be active, and during negative edge, slave is going to be active. So because during negative edge, what happens? Slave will copy the master. Okay, now the feedback is available. So if now the feedback is available, now at that instant, anyway, master is inactive. Though Q and Q bar are available, so at that time, because it is negative clock, so negative half of the clock pulse, so during this time, master is inactive. So since master is inactive, it can't toggle like that. So thereby it can't change the state continuously. So this is going to prevent the race around condition. Okay, so now let us finally see the truth table. So here only when the clock is present, it will be active. So when J and K both are same, what is this present state? So it will be the previous state only, that is Qn only. Okay, so what do we call that state as? It is no change state. So when clock is given and J is 0, obviously it is reset state. When J is equal to 1, we are going to get the output as 1, which is called as a set state. When both J and K are equal to 1, it is the Qn bar or the complement of the previous state, and it is called as the toggling condition. Okay, so this is how we could overcome this race around condition. Here is one waveform. So this waveform will give you more information regarding the master slave JK flip-flop. So here is the clock pulses that are given. So during these times, okay, so during positive, this positive edge and all, obviously master is active. So during negative edge, okay, slave is going to be active. Okay, so now let us see. I have tried to put all the conditions over here. So what are the conditions? It is J is equal to 1 and K is equal to 0. So if J is equal to 1 means it is nothing but set state. So during this positive edge of the first clock pulse, so it is the master output. So it goes to 1 state. Okay, so it goes to 1 state over here. So it is set until here. Next, J is 0, K is 0. When both are 0, it is no change condition. So since here it is set, it will continue with that state. After that, what happens? J is 0, but K became 1. So if K is 1, you know that it is reset state. So thereby from 1 it came to 0. So during this clock, what happens? Both are zeros. So when both J and K are zeros, so obviously it is no change condition. So no change means previous state was reset. So it continues to be in the reset state. Now during this positive edge, you could see that both are 1, 1. So when both are 1, 1, obviously it is toggle condition. Here it is 0. Previous output it was 0. So now it became 1 for 1 clock pulse. Okay. And then it continues to be 1 over here. Right. So thereby during this positive edge, what happens? Again toggling happening. So here from 0 to 1 it changed, and from 1 to 0 it has changed. Okay, so this is how we could understand the master output, and this is the output of the master, which is Q1 bar. So Q1 bar, it is the complement of Q1, that's all. And then here is the slave output. You could see that you will get the master output only, but it is active during negative edge of the clock. Okay, that is very important. So this is called as the negative edge. here is the negative edge. Okay, so this is the negative edge, and you could see that slave output, how we are going to get, it is copying the master during this time. Okay, what is the master output over here? It is set, that is 1. So because of that, here it became 1 like this. Okay, so it will be 1 until here, until it will get one more negative edge over here. During this time, what happens again, it is going to copy the master. So at this time master is 1, so it continues to be in the set state. Okay, and then it is going to change. So there is a small delay between the master and the slave over here. So when we do this, what happens is we are going to overcome what is called as the toggling condition, that is race around condition, we could eliminate. Okay, so here only toggling continues. So okay, obviously there is toggling, that is from 0 to 1 and 1 to 0, output is going to change. But so with respect to clock, you could see, so in the previous JK flip-flop where race around condition was available, here only there were so many changes from 0 to 1 and 1 to 0. So that is called race around condition, that we have eliminated over here by using master slave configuration. So by using master slave configuration, it is clear that we could eliminate this race around condition. So thereby just the toggling that is going to happen. That means if the previous state was 0, it goes to 1 state and remains to be in the 1 state. So thereby we could eliminate this race around condition by using master slave configuration. Thank you, students.